Yeah, hello guys. A new day, new stream. It's Friday. It's a long time I didn't stream, so started today. Unfortunately, I was sick for the last 2 weeks. I have some allergy issues. Also, looks like some seasonal stuff came in. But we will continue. So we stopped at our needcode.io structure. So last time we stopped at two pointers technique. So today we'll try to solve this two problem: container with the most water and trapping rainwater. So that's the goal. But besides that, I didn't manage to solve the problem of the day. So we'll be first trying to solve this one. It's unfortunately a different technique. It's not two pointers. It is a sliding window technique. But lately, the last week or so, LeetCode started to put this kind of problems. So what can we do? I guess this is what we'll start doing at first. So yeah, let me check if everything is ready. Okay, so just a moment. I do not see my stream running, so checking. Okay, yeah, looks like I'm up. Yeah, up and running, so cool. Yeah, let me put this on the right side. I have a new addition to the stream. If you guys noticed, it's I bought some LED stuff. So I have my nickname on the right, AWS AWXOLR. So this is my handle on Twitter, YouTube channel, also the same. So you can follow, subscribe to this YouTube channel, and so on. Another thing I forgot, I think it's music. So let me start my music. And yeah, it's a bit too loud, unfortunately, for me. So I will do it slowly. You do not hear it in the same way as I do, but overall seems to be good. Okay, so yeah, let's check it out and see what's the problem of the day. What's the trouble with this stuff? So, yeah, so we'll need to count subarrays where max element appears at least k times. Yeah, so this is a sliding window technique. Usually, if you have, let's say, in the title of the problem, things like subarrays, and maybe counting, max, another technique. So this may lead you to think that that's a sliding window. Okay, so yeah, we are given an integer array nums and a positive integer k. We'll need to return the number of subarrays where the maximum element of nums. So yeah, looks like first we'll need to find what's the max of this array appears at least k times in that subarray. So I assume if we go with this subarray, max doesn't appear at all, so we'll not count it. But if we go with this subarray, 1 and 3, max it's 1, which is less than 2, so we'll count it. But how many subarrays do we have between 1 and 3? So actually there is 2 of them. It's 3, 1 subarray, and 1 and 3 it's 2. So that would be like 2. If we move on the right side even more, we'll have another one. So we'll do a plus 1. If you go on the right side, even one more, so it will be another one. So far 4. Yeah, so where's how it's 6? Okay, so the subresult contains the element 3 at least 2 times are 1, 3, 2, 3. Yeah, I found this. 1, 3, 2, 3, 3. Wait. At least k time. It may contain even more time. Oh, so I misunderstood. Okay, so I need to find the subarrays which have 3 2 times or more, no 2 times or less. Okay, so that's the trick here. Yeah. Yeah, let's check a little bit the examples. So we have this 2 examples, 1 and 2. So for this one, we have max 4. So we need it to be at least 3 times, k being 3, which is not totally possible because we have it only 1 time. Yeah, I guess that's the problem. Let's the first thing which we'll do is set up our coding stuff. So let's create okay, so we need to count subarrays where max elements appears at least k times. So cargo new lib count subarrays where max lm what's that, max appears at least k times. I'd like to use the same name. It's easier to find, and then I'll put a number like the number of the problem to be able to find it later on. Okay, so cd count subarrays. Let's go inside, and I'll zoom it for sure for you for this to be visible. So I assume everything should be visible and right. So let's set up the problem. It's like I unfortunately didn't copy it. So struct solution. So we have our code there, and we'll need to define our scenarios. So I have a snippet to generate some helper code where I'll provide the scenarios, and I'll receive just the results. So here I'll have 2, and on the right side let's put it 3. I'll come back later to update the scenarios. Here we'll be just counting the subarrays, but I'll need to destructure my input. So it will be like nums and k, and we'll need to use it here. Okay, so yeah, let's continue defining our examples. So we have this one first, and we'll have another one. So let's add the second one. I think the second one was 1, 4, 2, 3. I think something like this. Okay, it was 3 and result is 0. Yeah, the goal is to have a result 0. Cool. Okay, we have pretty much everything set up. I will need to disable Copilot. We will not need it for this one. If you'll get into troubles, maybe we'll ask AI how he can solve this problem for us. Okay, so yep. Now let's try to work a bit on our whiteboard and try to figure out how can we solve this problem efficiently. Okay, so we have the first example. Is it though the first example? Yeah, 1, 3, 2, 3, 3, and k being 2. Okay, so this would be our whiteboard. So we have our example. We have this vector 1, 3, 2, 3, 3, and we have k being equal to 2. So first stage which we need to find out, it will be to find the max. I guess in this case we will loop for our vector. We'll find max being equal to 3, and then we will try to go with a sliding window technique, I guess. The sliding window technique. So what the technique would be in itself. So yeah, let me copy the vector above. So we have like 1, we have 3, we have like 2, and we have like 3 and 3. So mainly this technique implies that you usually start, you have like 2 pointers. You have like a left and a right pointer. Sometimes, or I guess most of the time, you start the pointer at the first position, and you try to expand this window on the right side to include or to see if you will achieve your goals. So in our case, we need to expand on the right till we achieve our goals. So how can we do this? So we start with both pointers at index 0. So yeah, let me draw the indexes here, 1, 2, 3, and 4. So we go on the right side, we expand on the right at first. So I guess I'll not need the below bar. So we'll move right at this point. Now we'll need to check how many counts do we have, how many max counts we have in this case. So max count in this case would be 1, because we know that max is 3 and it's 1, so we have 1. Is it a satisfiable answer for us? No, because we need k to be at least 2. So then we, I guess, move on the right even more. So we'll have our pointer, instead of being here, it was here. So we move it here at this position, at position like 2. So yeah, did it change the max count? No, it's still 1, because 2 is not equal to 3, so we don't increase the max count. So we have only this one here. Okay. Yeah, what else do we have? We need to move still on the right, so we expand even more on the right. So we move the right pointer to 3. So now, yeah, now count changes. So we have it at this stage. So we have not being 1, but being 2, because we have 2 3s. It's being equal to 2. So question is, how many subarrays do we have at this position? So I guess it's 1. Wait a second, I feel like I'm a bit... how many subarrays containing 3? So in this case, it's only 1 subarray, because this is the one. This is the one subarray which contains 2 Ks. So we can tell our algorithm, yeah, probably I'll have like a result, and I'll tell that my result is equal to 1 at this moment. Yeah, we are moving even more on the right. So we are moving here. count of this being a count of max count being 3, which is even better because it's more than 2. So we have another one because we had the previous one, and this one will be a new one, so it will be +1. So we have another subarray. In this case, the subarray being the array itself, including. So we, I guess we arrived to the last part. The question now is, can we have other subarrays which satisfies our condition? Yes, I guess we can decrease our window. So in this case, if R it's on the max side, maybe we can remove, so we can make our window a little bit less. So we move L in this case from position 0. It will not be here anymore, but we'll move it here. So we have another subarray because we know in this case that K didn't change. Max count 1 was not a free, so we'll not change C in this case. So this will be another subarray. So yeah, let me plus it here. I guess I'll just write it here for convenience. What else can we do? We move on the right side even more. So we move, we shrink again the window. But in this case, we know that L was a max counter, so we'll need to decrease the count being to 2. But we'll have another subarray here. And this will be another one. So the question is, where are the other 2? Because we have like 2, 3, 3. Yeah, probably it's this one. Yeah, this is a bit tougher than I thought. Because we have... yeah, okay, so I guess to clean this up a bit, yeah, let's go again, because I would like to use some different colors. So we have like 1, 2. I guess it's 3. What else do we have? Like 1, 3, 2. Okay, so it's 1, 3, it's 2, and then it's 3 and 3. So yeah, let me find all the subarrays. So first one being this. So I'll use this kind of bluish color. Yeah, let me get another one. Another one would be this. Yeah, another one would be this. And another one would be this. Yeah, probably I should use a different color here. Let me use some greenish color. And the last one which I see would be this one. So last it's this free stuff. So how many are there in total? So blue one plus this kind of light blue one. So we have this orange and cyan, 1 plus 1. And what else do we have? It's this yellow. But there is one more. I cannot find it. Yeah, let me check. It should be 6. So 1, 3, 2, 3. Oh, I think did I miss it? Yeah, I missed it. So yeah, there is one more with this structure. So this one, it's one more. So okay, yeah, looks like I found them. Yeah, this one would be another one of 4. So now we have all of them. It's like 6. Okay, so yeah, it's not easy, kind of. Technique is good, but we should think when do we shrink our window and when do we expand it? Because looks like my initial way of looking at those these things was not totally right. But before that, let me write a comment. I need to answer smalls. Okay, so yeah, let's try to code it a bit, and we'll see where we will get. So we are on our coding screen right now. Yeah, first stage we'll need to find max. So max will be easiest to find. It will be, let's have max. No, I think it should use an iterator and then use max. And this will give us an option, and I think the problem may be if it's empty, but we have constraints that it will not be empty, kind of. So let me use like this. So we found out the max number. Oh, hi Ramos. Yeah. Welcome to this stream. Yeah, welcome. Brazil, it's far away, but I'm glad that you managed to join. I live in an Eastern European country called Moldova, so. But I know people, and I do work with people from Brazil. So welcome aboard. Are you interested in Rust programming language or lead code, or how did you stumble upon this channel? Yeah, so I guess we will, for now, let's create our left and right pointers. So we'll have a mutable left, then we'll have a mutable right pointer, which starts, both of them starts at position 0. They will need to be use sizes, but right, I'll create it a bit differently. So for right, I'll use a range, rustlang. So we will be incrementing right in this manner. Yeah, max will be not mutable, but max count, it will change. Okay, so we have like figure it out a bit on the structure of the algorithm, because this will be our sliding window, so we'll need to expand. Somewhere here we'll need to collapse or shrink our window. Yeah. On YouTube, recommendation, best recommendation of the year. Oh, thank you. Yeah, I mean, there are a lot of let's say good teachers and person who explain on YouTube. I try to mimic them, some of them, and I try to fill this gap of beginner to middle knowledge on Rust. Because with Rust, what I've noticed is either there are super strong guys, like they write such code that I have no clue what does it do, and it's beyond me, and I feel like I'll be depressed that oh my god, when I will arrive at this level. Or there are like complete beginners. I somewhat want to fill the beginner to middle gap, and everyone who wants to learn a thing or two, yeah, it's welcome to join. So yeah, but thank you. I'm glad that someone from Brazil connected to this. Oh, it really makes me feel nice. Really good. Okay, so here, yeah, we kind of start shifting our window to the right. Now I guess we'll need to count our K and see if we have, yeah. Oh yeah, thank you. Yeah, I'm a bit lazy and was sick, but I feel like if I'll post more videos, maybe I'll grow my subscriber count. But so far, it still grew a lot, literally. This year, I think I started with 50 subscribers or something, and we are like 250. Which doesn't seem much comparing to other YouTubers, but for me it's like a huge improvement. So, uh, and I have like a lot of very nice communications or dialogues with people. So I'd like to continue keep it in the same manner, like question answers. So if you're interested in something specific or any questions which you have in your mind, so please write it down. I'll gladly answer if I know, because sometimes I may not know. Okay. Yeah. So yeah, we kind of have. Let me get back to this. We have the max. Now what we'll need to do, it's check because we are moving on the right every time. We will need to check if a current one will increase our max count, because for now we don't have any items in our max count. So let's check if nums of right will be equal to k to max. Then we'll have our max count plus equal 1. And I guess, yeah, I'll need to deal with this one because it's a little bit annoying. I don't want to consume it. I guess the simplest way would do something like this. So I've got my value and I will dereference it because I don't want to be it as a reference. Okay, so we have our max count. Now I guess what we'll need to do is check if it satisfied our condition. So if max count will be equal, I mean greater or equal to k, then we'll need to increase our result. I guess I'll need a variable for our result. So let me call it result for now. We'll do result plus equal 1. So that's our condition. Yeah. And the question would be what to do and when to shrink our window, because we are moving only on the right. And if we do this, I guess the result, yeah, kind of we can get rid of this one. So I can do result, and I think I'll need to, yeah, actually maybe I don't need to. Kind of need to shrink the window to count all the other options. So when do we shrink it? When do we shrink the window? So yeah, let's get back, I guess, to this board. So we have like 1, 3, 2, and 3, and 3 again. So we are here. Let's assume R is at this level. What's the option for us to shrink it? No, I don't see any reason to shrink. Let's assume we are here, because here we have like a full subarray. In this case, if we have our max k, probably we can. But yeah, still we don't have any. Yeah, I guess here we will need to shrink. Because we may miss. So if we are here at this level, so we have like a max count. In this case, it will be like 2, because we have like this one and this guy. We will need to see this subarray, because we can get rid of this one, we don't need it. So how can we shrink it? So what would be the condition? But at the same time, we will miss this one. That's tricky, kind of. Yeah. I'm thinking, how can we use the sliding window? Because I do not see. We need a key to do this problem. I don't see when we should move it on the right. I don't see a law. So, okay, so if we are, for example, at this level, if we are here, then we can start shrinking, but then we'll miss. Wait, will we miss anything? No, we counted this. Yeah, wait a second. So yeah, we are here. So we counted this one and we counted this one. So we have like 2 at this level. So yeah, let me put 1 and 1. So if we start shrinking here, so this would be 1. Yeah, I guess we'll miss this one. Yeah, that would be the trouble, because we are here with the R. So that's not clear. Yeah, I do not see though. How can we do it? Yeah, we'll spend a couple more minutes. If we'll not manage, we'll look at the solution. So yeah, usually I've learned if you have trouble solving a lead code problem, don't waste time. Just check the solution and editorial. So it is what it is. I mean, yeah, not always possible. So yeah, what's the law here? I did not see it. So yeah, let's read the editorial. Maybe we'll find something here. So yeah, the problem involves analyzing an integer array nums to count the number of subarrays in which the maximum element of nums appear at least k times, where k is given as an input. Okay, what's in a subarray we know. Algorithmically solving this problem involves traversing the array and tracking the frequency of the maximum element in a dynamic range. The algorithm should efficiently update the frequency as it progresses through the array. The problem is similar to scenarios where we need to find the frequency of occurrence of a particular event or condition within a given time frame or sequence. Oh, so it gives some ideas where this stuff may be useful. Which I really like, because this kind of problems are very weird often. So for instance, in financial data analysis, one might be interested in identifying periods where a stock price reaches its maximum value at least a certain number of times within a given time frame. This can provide insight into potential trends of patterns. Similarly, in network traffic analysis, identifying sub-intervals where the network experiences maximum data transfer rates beyond a certain threshold can be crucial for optimizing network performance or identifying potential issues. Okay, so now we have the problem itself. So we have an explanation on what's the sliding window, which kind of intuitively I understood that would be the way to go. Though I didn't manage to figure out everything. So sliding window emerges as a potential effective approach. The sliding window algorithm is useful when handling contiguous segments within an array. But two indexes, one which indicates the start of the window and the other the end of the window. Or it's like a left and a right in my case. As we traverse the array, we should maintain the frequency of the maximum element within the window. Yeah, we do this. Okay, so it looks like not the stuff I needed, so max count, or we can call it max frequency. We try to do this. Okay, so how do they suggest us to do it in a better way? Probably. The objective is to count the windows where the frequency is greater than or equal to the given threshold k. Yeah, that's the goal. To achieve this objective, whether the frequency of the maximum element in the window is greater than k, we initiate a process to shrink the window. Okay, so to achieve the objective, whether the frequency of the maximum element is greater than k, we initiate a process to shrink the window. Until the frequency of the maximum element in the window is exactly k to identify separate. Okay, so a trigger for us would be, if you go to the whiteboard here, here, once max count or max frequency is greater than 2, this would be the trigger to shrink the window. So I guess we will get to this level. We'll even count this level, so R would be here. And then we will start shrinking. So L will be here. Yeah, this I got it. I mean, intuitively I can understand this, though I cannot figure out how to include this one, because I'll kind of need to move R, or the right one, move it back, which defies the whole purpose of the sliding window technique. Okay, so let's check more. Okay, so we know once k is greater, we shrink the window, or make the left, we increase the left pointer. Let's put it this way. The index variable start accounts for multiple starting position for valid subarrays where the frequency of the maximum is at least k, the current ending position. Let's track this by index variable end. By adding start to the answer, we ensure that we account for all valid subarrays ending at the current index end. This is because of the fact that for a given ending position n, there exists a start plus one possible starting position, each contributing to a valid subarray. Oh, so there is a trick to that. Okay, so let's check the algorithm. We initialize variables max element. Okay, we do have that. We have ans, start, and max elements in Windows. I'm not sure I got what does max elements in window. Oh, so that's the frequency of max element. Okay. Start is the pointer for the start of the window. Okay. Ans will be the final count of subarrays meeting the condition. Okay. Max element, it's okay. Okay, so iterating through the array. So let's try to iterate through each element of the array using a for loop with index and ranging from 0 to the length nums. yeah, we do this. So step number 1 and step number 2 we do. So like we have our max, we have max frequency, we have result. I guess I can call it ans. Maybe I'll do like a start, and this one I'll rename it and to be easier to follow. I'm not sure I like this one, so I'll keep my max frequency because that's what it is. So sliding window to meet the condition. Use a while loop to shrink the window start pointer until max elements in windows is equal to k. Oh, ho, 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 ho. Okay. So yeah, kind of that's cool. Yeah, while max frequency is greater than k, we will be shrinking our window. So this means we'll do the following operation. We'll do like start plus equal 1. So that's the first thing. But I guess before that, we'll need to check if nums of start was max element. How do I call it? Or just max. Then we'll need to decrease the max frequency minus equal 1, because we will remove this. We'll move on. What else do we need to do here? Is there anything else? No, we reduce this, we increment this, so this will be shorter. So yeah, we decrement this is equal to max element. Okay, that's clear. And we increment start. This is what we do. We check if this it's equal to max. Yeah, let me name this one max element to be more consistent with the algorithm. Yeah, so step number 4, it's achieved. Now let's check counting subarrays. Add start to the answer variable. Okay, so add start to the answer variable. This is done inside the for loop, so it accumulates the count of subarrays meeting the condition. This I not really got. Okay, answer plus equals start. Yeah, kind of I understand this now, but I'm not sure I figure it out by myself. Yeah, we'll need to okay, so what's start? I guess this will be as I32. I64. I don't know why they decided to go with 64, but let it be. But what do we do with the and? Yeah, I'm not sure I understand this. I guess we will need to use and to increment our max frequency. So if nums of and it's equal to max element, then we do max frequency plus equal 1. So yeah, let's double check the algorithm. I'm not sure about this. I mean, everything here is logical, but this part, I guess it's a mathematical thing or something. Maybe it will work right away. I don't know. Let me run it. left 2, right being 6. Okay, so it doesn't work at all, literally. Yeah, then looks like we missed to do something. So yeah, let's get back. Add start to the ans variable. This is done inside the for loop, so it accumulates the count of subarrays meeting the condition. So what did I do wrong? Yeah, we'll probably will need to go with the debugger where we missed a step or something. So let me check this one. Okay, so we have like a left and right. Unfortunately, I cannot shift. Complexity, we can track indexes of max element. Yeah, I would like to stick with this one because it looks like I didn't implement it. Okay, so counting frequency of max element in the current window. Okay, so check if the current element nums I is equal to max element. If true, increment max element. Okay, we do this. If true, if max elements in window is as it represents the frequency of max element in the current window. Use a while loop to shrink window start pointer until max element is equal to k. Inside a while loop, yeah, but okay, so we have this while k it's so we receive k max element. Okay, so we have like found the max element, we have answer, we have a starting point. So if it's equal to, we reduce it. Yeah, probably this is an optimization or something, because it doesn't do the things which I was expecting it to be doing. This one, it's exactly what I'm doing. Okay, so yeah, we have we'll look a little bit on the Python part. So we have max element, we have answer, we have start, and we have max frequency. Everything equal to 0. So probably I even can copy this code. Yeah, we do this and range exactly as we do. We check this, we increment exactly as we do. But here is the trick though. If max elements in window is equal to k, it's not greater than k, but it's equal to k. Then we shrink it. Okay, so that was the mistake. And now everything works. Though I'm not really sure I understand the idea behind it. I mean, maybe you guys do. But I personally do not. I do not understand this start stuff. Okay, so let me, I guess, yeah, we'll need to go on the whiteboard. Let me get a screenshot of this code to have it there as a reference. Let me use a new canvas. So we have this code here. Okay, so we have our logic 1, 3, 2. Hopefully it's seen properly. We have start here. We have end as well here. So these 2 pointers are here. Okay, so what do? We found out that 3 is max. We do like nums and equal max element. Yeah, we increase the frequency. So I'll use, yeah, let me create a variable No, I didn't want to do that. So it's D, I guess it's D, yeah. So it will be like start and it will be end, like 2 pointers, and let me switch color, and I'll have like frequency. For now it's 0. Frequency is 0, and answer it's also 0, so I'll call A. So we are at this stage. We go nums of and it'll be 1. It doesn't increment anything, so frequency will be 0 again. We check if while max frequency is equal to k. It's not, because k in our case, yeah, let me put k here, being 2. At this stage it's not 2. So this while loop will not be executed, so we move on. So in answer we will be increasing with start, but start is 0, so pretty much this line will not do anything. We move on. So and will be moved from here, it will go to here. What will change? We'll do this logic, so frequency will be increased to 1 in this case. While max frequency equal k, it's not, so this while loop will not be increased. Answer plus equals start as well. Start remains the same, it's not changed, so we'll not add anything. We move on. And will be here at this stage, it's 2. Not increased. Frequency will not be increased because 2 is not equal to max. We move on. We have a change here, so frequency will change. So now we'll apply our while loop. So okay, so we check if max frequency equal to 2, I guess to k. In our case, frequency is 2, it's equal to k2. So this while loop will be executed. We check if num start is equal to max element. No, because we know start is 1. It's not equal to max element. Then max frequency remains the same, but we increment start with 1. So start will go here. And what we'll be doing the next stage, because if we go outside, max frequency is still 2. It was not changed. We'll do again this operation, num start equals max element, and in this case, yes, it is. So we will reduce the max frequency to 1. So max frequency will become 1 at this stage. We'll increase start with 1. Yeah, so start will go at this step. And it will exit the loop. And the answer will be like start will be plus 2. So our answer will be suddenly plus 2. What does it mean actually, plus 2? I mean, it's like a mathematical thing or something. Because, I mean, it works, it just works, but I guess initial vector was this one. So that was 1. And what's the next one? I guess this one is the next one. That's the idea. Yeah, probably this is what 2 means in this case. Yeah, but let's move on. Let's move on. Okay, so whatever. So answer at this stage is 2. Frequency, it's 1. So we have and we'll move on because and was this, but we incremented and, so and will get here, and frequency would be 2 again plus 1 because of this, so we have 2. What does it mean again? We enter this max frequency k. Start is not equal to max element, so frequency doesn't change. But start will be free in this case, so it will move the here. Okay. We do again because k max frequency didn't change. So k in this case would be like we go again inside, but in this case it is. So we'll remove again. It will be 1. And start will increment start plus equal plus 1. So start will get here, and we'll exit the for loop. So this will be like 0, 1, 2, 3, and 4, and answer suddenly become plus 4. So yeah, I mean, I see it how it works, but I still cannot figure it out. How did they figure this out? I mean, yeah, maybe they explain this because I do not get it. Sorry, guys. Maybe I'm not as genius. I cannot figure out how this is formed. Yeah, it works just perfectly. I can understand this. It gives us the result. But okay. So this was called like 2 times. So it's sort of combinatorics or something. Yeah, let me check back the logic. Okay, so probably this part, it's where do they explain it? Okay, so let's read it again and try to figure out how and why. The index variable start accounts for multiple starting positions for valid subarrays, where the frequency of the maximum is at least k. At the current ending position, let's track the index by variable end. Okay, so by adding start to the answer, we ensure that we account for all valid subarrays ending at the current index end. This is because of the fact that for a given ending position end, there exists start plus 1 possible starting positions, each contributing to a valid subarrays. Oh, I don't understand. But yeah, let's try. This part is important for me. This is because of the fact that for a given ending position end, there exists start plus 1 possible starting positions, each contributing to a valid subarray. I don't understand that. I'm not sure. I'll spend a couple more minutes here. Yeah, I'll firstly check if this works, but so yeah, let's pick some random stuff. So let's assume we got here. So yeah, we have our vector 1, 2, 3. Okay, so 1, 3, 2, 3, and 3. So we are here, start, and end will be here. So at this stage, we have like start plus 1 possible solutions. Okay, I mean, start is 0 plus 1. Yeah. Kind of, it's 1 start. Let's assume we are here. I mean, some sort of law or something, which I don't get it. So this is 1 and this is 4 again. So here, how many do we have? So we have like 2 of them. We have this. And what's the second? I mean, I guess it will be this. So it will be like s plus 1. So this would be like 1 plus 1, which will be 2. Yeah, this works. I mean, oh my god. That's pretty interesting. Yeah, let's check it here. So it's 2, so we are here. And it's here. So this will be like, I guess, 0, 1, 2. And this 4. So how many of those we have? I guess it's only 1. And that's it. No, I still don't get it. I mean, I don't know. This formula of this, at any start plus 1. So where do they get like 3? Maybe it counts as well for the previous ones as well. I don't know. Okay. Not smart enough to understand this for now. Probably it's just a trick where you need to know it and that's it. Okay, so let's check our solution on LeetCode. If this works, then we'll move on because we have a couple more problems to solve. So yeah, this works. Yeah, let's check if all scenarios work. Cool. Yeah, I do have like a streak of 94 days, which is impressive even for me, to be honest. I never did like such a long streak. Oh yeah. So this is the code. I guess we can check what other people did, which I feel like it would be exactly the same. And maybe this is more logical, you know? Yeah, I feel like this is more logical. I guess it's the same way, but the idea is we will... Yeah, I guess, I don't know. It's a bit different approach, but it's more logical, it feels like. Because mine, I just implemented the algorithm suggested, but everything is logical till this stuff. This I don't get it. How suddenly, if we add start, it will be the number of combination of... I wouldn't figure it out ever. Yeah, ans plus equals start. This stuff, I cannot figure it out. Anyway, it worked. -1 problem. Really, really good. So I guess we can get back to our roadmap. So let's dive into this one. So this would be a two-pointer technique. A greedy two-pointer technique. So yeah, let's set up everything and continue with the implementation. Okay, so I guess we'll be committing this, but a little bit later because I don't care for this for now. So yeah, let me create another library. So container with most water. Container with most water. So number 11. Let me zoom it up. And set up everything here. Set up logic. Struct solution. We need to find some area. I'll write a to-do here. Let me copy the scenarios. So we have only a vector, which is good. And we'll need an output. So let's assume some things here. What else? What else? So we will be calling the solution with the max area on the input side. So yeah, let's add a couple of scenarios. So we have example 1, which would be this. Yeah, we didn't figure out the problem yet, but we set up our code structure. So this vector will need to be equal to 49. What 49 is, I don't get it yet. But let's set it up, and we have another one like height 1 1 will be equal 1. So this will be 1, and on this side we'll have 2 1 1s. Unfortunately, Rust will align it a little bit differently, yeah. Okay, so now let's read the problem. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of I line are I0 and I height I. Okay, so it's some sort of coordinates. Okay, so yeah, let's see. Here, for example, we have 1, and this would be like a height 1, and this would be 8. Like, it starts from 0 and moves up. Okay, so x, y coordinates. Find two lines that, together with the x-axis, form a container such that the container contains the most water. Oh, interesting one. Return the maximum amount of water a container can store. Notice that you may not slant the container. Yeah, slant, it's a new English word for me. I don't know what does it mean. Probably bend or change, or I don't know what exactly, but logically, here I assume these two red stuff, we can fill the water inside. So we'll have like max height being, okay, so here is an explanation. Okay, in this case, the max area of water, blue section, the container can contain 49. So why 49? Area, so what's area? Area will be length multiplied by height. So height in this case would be like 7, okay, and length, I assume it's 7 as well, yeah, so it's 1, 2, so okay, 1, 2, 3, 4, 5, 6, 7. Okay, so it's 7. So 7 by 7 will be 49. So we kind of need to figure out an area like this, which will be the max. So yeah, let's dive into our whiteboard. Probably I would need this example as a reference because it's a bit more data. Here we set it up. We'll get back to coding it a little bit later on. We have our code here. Yeah, maybe I can zoom it a bit. Yeah, it's sorry for the quality. Probably it's a bit too. Yeah, it's a bit too zoomed in. I'm not sure if I did what I did. It makes sense. Yeah, let me go from scratch. And here, probably it's too thick. Yeah, that's a bit too thick. Okay, so we have our grid. Do I need to draw a grid? Maybe I will. So yeah, let me draw this bar. So we have like a big bar, we have a smaller one, we have like a, yeah, that would be a bit problematic because I'll need to draw a real grid. Otherwise I'll have like troubles. So yeah, anyway, yeah, we kind of need to. So yeah, this would be like y-axis, and this will be like x-axis. So we'll have like how many of them? It's 10, 9, 9. So we have like 9. So probably I will do like this one to be 8. Here we'll have like 4. This one will be 0. Yeah, here will be like 2. Here it will be like 6. And I guess we'll have a 9 somewhere here. So I will not put it for now. And on the white, okay, so this will be like y, and this will be like x. Max would be 8. So yeah, let me put here, it will be 8. Middle will be 4. This one will be 2. 6. So yeah, let me add a couple in the middle, but I'll not put the numbers. So yeah, let's fastly draw our stuff. So we have our first bar. Yeah, I guess it's not correctly drawn. The second one would be like a bit bigger. Yeah, we do have a drawing stream. This one would be like 6, and it's the third one. Yeah, something like this. Then we have a 2. Then we have a 5. So 5 being 5 as well. Then we have a 4. Yeah, probably I'm wasting some time now, but at least we'll look good on some thumbnail. We have another 8 here. So somewhere here. Okay, so we have a 3. And we have a 7. So this one would be a 9. And we'll have a 7 somewhere here. So yeah, we have our bars. Yeah, let me, I may even use a different color, stuff like this. Maybe it's not the right choice for the color, but doesn't matter. So we have our bars. Now we'll need to figure a 2-pointer algorithm, which will give us the max area. We know it's a 2-pointer because that's by the topic. And usually 2-pointer algorithms start one from the left side, one from the right side. So we'll have one starting at position 0, and the other one at max position. So let's assume we have our solution here. We have our starting point will be here. Our ending point will be here. We're the second. So maybe I'll use like left and right. So we have our 2 pointers. But probably in this case, yeah, I didn't start properly because it's not first. I guess it should be here, but it doesn't really matter, to be honest. I should have shifted them one on the right side. So yeah, left would be not at position 0, but it would be here. So, and right would be here. It doesn't really matter because the distance would be pretty much the same. Okay, so what would be the area of these two? How do we calculate the area? So the area would be this small stuff. Yeah, what does it mean, small stuff? It will be the minimum height between these two bars, between height at position L, and it will be like min between height at position L and height at position at right. So that would be the minimum. This is one thing, and we'll need to multiply it by the distance. And how do we calculate the distance? It would be like right minus left, because we have this the distance. So if here is 9 and this is 1, so we have 8. The distance will be 8. So it will be like 9 minus 1, and it will be r minus l. So this would be the definition of the area in our case. So we have the formula. And now we will need to maximize somehow the area. So I guess the logic would be if you have a big one on the right, does it make any sense to... No, I guess we will just move on the right side. We'll increment left. Because we'll increment left because left is smaller than right. So here we have a height of 7. So this would be like 7. Let me switch color. But here the height is 1. So 1 is definitely smaller than 7. And we'll move the left pointer here on the right side. And now the new L will be kind of 8. So by applying the formula, we'll have the min between HL, which will be 8, and H right, which will be 7. So minimum here will be 7. And we'll multiply it by right minus L. So 9 minus 2 will be 7. And we'll have a new area of 49 in this case. So this is actually our solution, because that would be our new area. This will be our new solution, but we are not sure. I mean, we don't know at this stage. Maybe inside there will be something. So in this case, does it make any sense to shrink it on the to move the left pointer on the right? No, because we have like a maximum point here, so we want to maximize the area. So maybe in this case we'll just shrink the R. So we'll move R to the left, because R is 7, but this is 8. So R it's we'll move it to this side. So new area will be like this is I assume it's 3. So minimum of this two will be 3 multiplied by 8 minus 2 would be 6. So a new area will be 18, which is less than 49. So max still will be this one. So we can apply the same thing, same principle here. Here we'll move again on the right. The trick though, we have here another 8. So what should we move? This one on the right or this one on the left? And that's, does it matter? I don't know. I mean, probably we can go further with an optimization like, I don't know, we check if this one is bigger than this one, maybe go with this one. It's like a look ahead, some sort of look ahead algorithm. But I'm not sure. I mean, probably it's a bit too complex. Okay, I guess overall the algorithm is quite clear. What's remaining is to code it. So that's the tricky part, because we'll need to play with pointers, and every time when you play with pointers in Rust, you have out of bounds issues. So that's the unfortunate stuff. So yeah, let's create a mutable variable called max area. First, I'll just set it to 0, because we will maximize it. What else? I'll have like 2 pointers. Which will be height of land -1. So we go 1 from the left, at most left, which would be starting at 0, and at most right, which would be right. Probably I'll need a formula to count the area. So maybe I can do a helper function. Maybe, yeah, let's create a helper function which will compute it. So we can call it area, and we'll be providing like the left pointer, which will be usize, the right pointer usize, and we'll provide the heights, which will be a reference to our back of I32s. Then result would be an I32. So yeah, we need to do the mean stuff. I guess that would be heights of left, mean heights of right. So that will be the mean stuff, and we will be multiplying this with the distance, so right minus left. But the trick is this would be like usize, and we'll need to cast it at I32, and everything would be nice. So this is our formula, which we defined on our whiteboard. Okay, so helper function we do have. We have the max area. Now we'll need to have our while loop. So most of the time with this kind of algorithms, we do while left is less than right, because we don't want for the left pointer to go beyond the right pointer, so they will need to meet somewhere in the middle. So probably they will meet here. Depends on the solution or the algorithm, but often with the 2-pointer technique, left goes on the right side, 1 position, 2 position, X position, right goes on the left side, and they meet in the somewhere in the middle. And the moment they are on the same index, our while loop exits. So yeah, so we have this stuff, left and right. Let's compute the area. So now we'll need to compute the area. So we'll have like local area. Yeah, probably here I'll need to return max area. And this is what we want to do. So local area, or just area, I don't know, would be like left, right, and height. So this would be our area. What's the trouble? Yeah, I'll need to call it with self. Okay. So we have our local area. Now what we'll need to do is redefine our max area. It will be max area, max between local area and current area. Or I guess not local, but we can call it current. It'll be like current area. So we have this part. Now we'll need to think on the logic when we'll move to the left and when we'll move to the right, because we'll need to increment this 2 pointers like left and right. So the logic is if nums, or not nums, but height. Yeah, it looks like here I put it to be heights. Yeah, maybe heights would be, because it's heights, not height. Heights of of left, it's greater than heights of right. If we do have this, this means we'll need to move the right stuff. This means, I guess we can do equal as well. We'll do right minus equal 1. Else if it's smaller, then we'll do left plus equal 1. And I think that should be it. Let me check again, run it in my head once. Let's see if this will work or not. So we have max area, we compute the area. We have this formula here. I extracted it in a small function to read a bit better. We update the max area if it's something bigger. If the heights of left is greater than heights of right, then we decrement the right pointer by 1. Else, if this is smaller, then we increase the left one by 1. We repeat the procedure. We update things. Yeah, this should kind of work. Awesome. So it does work. We check the tests. It does work. We copy this part. We apply this here. We run. And we submit. And it's a pretty fast algorithm. We are on the left side of things, so it's pretty cool. Okay, so how long are we streaming? So it's an hour and a half. I guess we do have time for one more problem. So this one, it's done. I guess the next one would be trapping the rainwater. So yeah, let's trap some water. Oh, so this one is a hard one. This one, it's a hard one. Though, dynamic programming, stack, monotonic stack. Okay, so a couple of ways on how we can solve it. Yeah, let's see. Maybe it'll not be that hard. Yeah, so this one is already done as well, so I may commit at last. Yeah, I don't need this. I'm not sure why every time it's okay, so I guess we can have it here. Git status, git add, git commit. Solved the problem of the day plus a 2-pointer media or whatever. So yeah. So I have a lot of problems solved, and let's set it up. So trapping rainwater. Cargo new lib trapping rain water. So that would be problem number 42. And we need to open a VS Code. We open it. Yeah, let me zoom. Set it up, because probably we'll need to debug it. Maybe, maybe not. Let me do a to-do here. Yeah, so it looks like similar structure with heights as the previous one. Yeah, somewhat they are similar in concept. Maybe. Yeah, this is some how it's called, Tetris problem, probably. Looks like some Tetris things where you need to count probably how many points will you make or something. I don't know. But yeah, it's with water, so yeah, no water. Okay, yeah, let me copy, I guess, a couple of scenarios. So we do scenarios, we have this vector, and the output should be 6. Yeah, I hope it's not like the first problem where I need to spend like half night trying to understand why we've got this result. But at the end of the day, the technique is what's important. So we need to know the technique on how to solve such kind of problems. Oh, it's a bit bigger. Okay, so yeah, let's define the solution. Struct solution. Okay, it's a little bit hot here. Okay, so we define this. Yeah, we missed this part. So we have like solution, and we'll need to trap. So we are trappers. We'll need to trap something. Yeah, test do not work. Of course, because we didn't implement anything yet. And my energy levels are a bit low though. But yeah, let's check. Given an n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. The above elevation map black section is represented by array. In this case, 6 units of rainwater blue section are being trapped. So we have like some sort of bars. Yeah, this one has a height of 0. This one is 1. Okay. This one, it's 0. So we have a 2, and then a 1, then 0, 1. So this one is a 3. And so on till we get 1. So in order to trap water, we'll need to be bounded by some bars like this. Yeah. So here we cannot trap water because we don't have a left bound. We don't have a left bar. But in this one, in this space of 0 and 1. Okay. How much water can we trap here? And if we try to use the same approach as with the previous one. So if we go, for example, let's assume it's the similar example. Because yeah, let's see here. So for example, how much water can we trap here? Why cannot we trap at this stuff water? Because we don't have a left bound. Okay. But at this level, why cannot we do it? Because yeah, at level 1, why cannot we trap water here? Because on the left side we have 0. But what's on the right side? What's the max, I guess, on the right side? Maybe we can move forward, some sort of moving forward to look what's the max. It's like 2. Okay, so 2 it's on this side max. But does it matter? Because for example, yeah, let's assume we don't have anything on the left and it will spill, because that's the trouble. But let's assume this case where we can trap water. So here at this stage, what's important for us? Because we can trap again the mean between left and right. And what would be the mean between left and right? So mean would be, so the same concept as area as we did on the previous one. So this would be, the formula I guess would be something like mean between the left and the right bounds. Okay, so we'll get the mean. Okay, so mean between left and right, so that would be the formula. Wait a second. Yeah, but for this, oh, and minus height. So mean between left and right and minus height. So that would be the formula. Okay, let's assume. So for us, it's important the left and the right pointer. At this stage, so if you go iteratively, let's assume one pointer it's, yeah, let me probably copy this and move it on the whiteboard and play around there. So yeah, copy of the copy of the copy. Because I don't want to spend like another 20 minutes drawing it. Okay, so let's assume we start with the pointer here, the left and the right. And we apply the formula. What does it mean? What's our formula? So our formula will be the mean between left and right plus or minus, I guess minus the height of this bar which we're in. But we are 0, so it will be 0, height will be 0, right will be 1, but it will be like 0. Mean between will be 0, height will be 0. So how much water can we trap? By this formula, it will be for For index position 0, it will be 0 water. So if we move 1, so for example for this, so this is 1, index 1, applying same formula, left, yeah, we'll move left pointer, I don't know about moving the left pointer though. Okay, whatever. Let's move the left pointer. So left and right. So we have 1, because here we have 1 and 1. But we don't know. But does it matter though? If we have anything bigger, because still we will not be able to trap more than this, because it will be spilled. Even if we have anything bigger than this one, we don't care. So we assume that this would be the max for now. So we have min L and R being 1s, and H being 1. So we'll have like 1 minus 1, and it's 0 again. So yeah, we cannot trap anything here. So it'll be 0. So we move on at this one. So 3, position 2. What else? So left. But I guess we'll need to keep not left, but we'll need some sort of max left. Because this would be bounded. So yeah, we'll keep the max left and max right some sort of. Yeah, I have trouble to code this, to be honest. But yeah, let's check. So we have like max left and max right. So let's assume we've got this stage. So max left, yeah, it will be like max left and max right. So we've got 1. So it will be 1, and this would be 1 again. So we'll use 1 minus height 0, and we'll have 1. Okay, so this would be trapped. So we finally managed to trap 1 unit of water. So I guess we move on with our index. It will be like 3. And we will be updating our max, because max would be like 2 points now. So max left would be like 2 instead of 1. And max right, it's again 1. Yeah, I'm not sure when do we when do we shrink it? Oh, I think I know when do we shrink it. We shrink it right now because we need in order to trap water to not be spilled on the right, we need this stuff to be equal or less than this stuff. Otherwise, everything may be spilled. So we'll be moving in this direction after this part. So we are here, so let's assume it's 2. Can we trap anything here? So the min between these two, it will be something like 1 minus height 2, and it will be like -1. So I guess -1 is not good, so we'll consider it as 0 or something. Because yeah, we cannot trap anything. But if max left is greater than max right, In this case, we need to move from this direction, that way, to shrink it. And how we'll do it? So we'll still have like a right pointer, but we'll have a max right, max left. Okay, so kind of overall, I got the idea. I've got the idea, though I'll need to code this, and that would be a bit trickier for sure. Okay, so this would be a bit trickier. Yeah, and I feel like yeah, we'll need to code it today. This will be troublesome. I'll spend a lot of time next time to figure it out. Yeah, but at the same point, I want to do streams a bit shorter. So wrap it in 1.5, 1.8. So yeah, I guess the simplest way I'll do it just tomorrow. So tomorrow I'll have another stream where we'll be just coding this solution of this problem. So that would be the easiest way to do it. Because I don't feel very well. I don't feel like I'm recovered. But yeah, we'll continue tomorrow, guys. So we'll code this problem and move to the next things in our list. So that's, yeah, it's a hard problem, so probably will take us an hour or more to finish it. Yeah, let's get back. So next thing will be stacks. So we'll be solving a couple of problems from stacks. Yeah, that's one of my favorite problems. I'll tell a story how I won a Olympiad, a competition, because it's a funny story, though I'm not very proud of it, but I managed to trick the arbiter that I solved the problem. I didn't know how to solve it at that time, and I have like this funny story about it. So yeah, cool. So see you tomorrow. Probably same hour, maybe a bit earlier. We'll check. So thank you guys for joining in. Please like, subscribe, and leave some comments. Any new preferences or ideas? How can I improve my stream? It will be a nice. It was a nice stream for today. Pretty productive. We solved two kind of problems and dig into many others. So yeah, wish you a good evening. Bye bye, guys. So yeah, let's end it.